Video is part 2 of networking devices. If you haven't watched the first video, I highly recommend you watch it as this video builds on that video. I'll put a link to it in the description. So let's get started. Imagine a person very far away from you and you're trying to send a message or communicate with them. Due to the distance, even if you yell, your voice gets softer. A similar thing happens on a wire. When a wire is too long, the data degrades as it gets softer. So not all the data is received by the other device. For this reason, we use a repeater. A repeater regenerates and amplifies the signal so that it can travel a farther distance. Think of the repeater as a megaphone. It catches your voice and just makes it louder so that your message or data can travel a farther distance. So a repeater regenerates the signal, but it can only do it between two devices. That's it. If a host wants to communicate with a third device, the repeater won't be able to do that. That's where we use a hub. It's basically the same thing as a repeater, but it regenerates the data to multiple hosts. Think of it like a multi-device repeater. So if this host wants to communicate with this host, it sends data to the hub and the hub sends it to this device or host. But it also sends it to all other devices, and that's a problem. So this is where we use switches. A switch is basically a smart hub which sends the data to the specific device that the data is meant for. This way the data is directly travels from the sender to the receiver, making the data more efficient and most importantly secure. Switches use MAC addresses. They're to identify where the data needs to be sent. MAC addresses are like IP addresses, but they're there for different purposes. I'll make another video explaining the differences. For this video, all you need to know that a MAC address is just like an identifier or a name of the device that the switches use. It's like an ID that every device has. So this is what a real switch looks like. For example, the blue wire is connected to host 1 and the red wire is connected to host 2. So when the data travels through the switch, it comes into this switch and then it goes out to this switch. So all devices have MAC addresses, but how does the switch know which MAC address belongs to which device? It knows this because it stores all of this information in its MAC address table, where all the MAC addresses are linked to the port numbers, these ports. So when host 1 wants to communicate to host 2, it sends the data to the switch with a label, and it will put the source MAC address from where it originated and the destination MAC address where the data is supposed to go to. So when the switch receives it, it checks the label and sees the destination MAC address. It checks the destination MAC address in its MAC address table. It sees that, oh, this belongs to host 2 and it should be sent out port 24, this port. And then the data is sent out to port 24 and host 2 receives it. And finally, let's talk about routers. In this example, we have 3 hosts on this network and another 3 hosts in this network. And we also have a switch for each network. So when you're trying to communicate information within a network, you use a switch. And a switch is only limited to transferring and communicating information within a network. Same thing for this network. But if you want to send information from this host to this host, you send information to your switch, and then the switch sends it to the router, and the router sends it to the other switch and then to the host. A router is used to send information between networks. Unlike switches, routers use IP addresses. To recap, IP addresses is a type of identifier given to devices in a network. I'll make another video explain the difference between IP and MAC, but for now, just to understand that IP addresses are just identifiers for the devices. Routers also connect to different networks, like your home network or the internet. The internet is a bunch of just routers that are interconnected. That's it. So when you're trying to communicate information between two networks, like your home network or the internet is just a bunch of routers that are interconnected. So when you're communicating with another device on another network, you send the information through a router. And then it goes through a series of routers depending on how close or how far the other device is. And this is the internet. That's it. It's just a bunch of interconnected routers. So when the host wants to send information through the router to another network, it is classified as communicating through the internet, as it's communicating to another network. Internet stands for interconnected network. So it doesn't matter if you're communicating to another network only using this router, or you're going through a bunch of routers to get to the other network. It's classified, both of those classify as using the internet. Routers are also traffic control points. This is where security procedures are implemented for the network, and firewalls are attached and redirecting the data based on a destination IP address, and sends data where it needs to go. Here we have a wire or connection. This connects the router and the network. This is what we call a route. Which is used to transfer data between the router and the network. Just like a switch, a router also has ports, and each port is an interface. Think of an interface like a doorway. Just like a doorway is an entry or exit point in a building, an interface on a router is an entry and exit point for data in the network. When data needs to travel from one network to another, it goes to these doorways, these interfaces, these ports. Each interface on a router connects to a different network, kind of like having different doorways to different rooms. So if your router has multiple interfaces or multiple ports, it can connect to multiple networks, allowing data to flow between them. Just like each doorway in a building leads to a different room, each interface on a router leads to a different network. Okay, now think of a network like a house. To enter and exit, you need to go to the door. So door is the router. But what if there are multiple doors or routers? I'm not talking about router ports. I'm talking about there's like multiple routers connected to what network. So this is an example of router, this example of router, this example of router, this example of router. All of these paths just help you go in and out of the house. So when there are multiple routers, one router is picked as the default gateway. Gateway because it is a way to go in and out, and default because it is the main door. Think of the main door as the one that everyone uses and everybody knows about. It's clearly marked and leads directly outside, and it's the most straightforward way to leave the house. And the other routers or these other doors are think of them as side doors or the back doors. These are also other routers that have important purposes. These doors also let you go out, but they might have specific purposes or specific uses, or they'll only be used under certain circumstances. For example, you might need to use the back door to go to the garden. You might need to use the garage door to take the car out. But these are there for specific purposes. But if you just want to go out in the easiest, fastest, and the most efficient way, you would use the main door, aka the default gateway. And that's it for this video. If you have any questions, drop them in the comments, and I'll see you next time.